Hey everyone! If you think space exploration couldn't get any more mind-blowing, buckle up because the James Webb Space Telescope has just shaken the foundations of our understanding of the universe. Scientists recently discovered something that wasn't supposed to exist. What could this cosmic anomaly be? And what does it mean for the future of astronomy? Let's dive in and find out. Coincidences often defy simple explanation. Imagine this, a game of pool. The balls are arranged in a tight triangle, and the player takes the shot. The cue ball smashes into them, scattering the balls across the table. But then something extraordinary happens one by one. Against all odds, every ball rolls into the same corner pocket. What would you think in that moment? A rare fluke? Unbelievable skill? Or would you wonder if something unseen, like a tilted table, was at play? In the universe, some events are so improbable they stretch the limits of reason. Picture this, a massive object hurtling into our solar system. Its immense gravity pulls a planet out of its orbit, flinging it into interstellar space. Now imagine it doesn't stop there. It drags a second planet along, and somehow, these two planets align so perfectly they begin orbiting each other as they drift into the void. It sounds impossible, right? Yet, improbability doesn't always mean impossibility. And that brings us to the latest discovery from the James Webb Space Telescope. The JWST has just revealed something astonishing in the Orion Nebula, something that may challenge everything we thought we knew. Stay tuned. Deep within the vast stretches of interstellar space, where stars are born, the James Webb Space Telescope, JWST, has uncovered something astonishing: two rogue planets locked in a binary orbit. Each of these planets has a mass similar to Jupiter, earning them the nickname Jupiter Mass Binary Objects, or JUMBOs. But here's where it gets even more fascinating. JWST didn't just find one pair. It found 40. Yes, 40 JUMBOs, making up nearly 10% of all the free-floating planets detected in the Orion Nebula. This discovery isn't just unlikely, it's downright mind-boggling. Scientists are now wondering if we're missing something fundamental about how the universe works. Could our cosmic table be more tilted than we thought? What's clear is that our current understanding of star and planet formation needs a serious update. But how? That's the big question. These JUMBOs were first spotted in October 2023 when JWST's advanced instruments captured high-resolution images of the Orion Nebula. While they may exist elsewhere in the universe, they've been notoriously difficult to detect until now. Their relatively small size and the limitations of existing detection methods, like gravitational microlensing, kept them hidden from view. Gravitational microlensing is an impressive, yet improbable phenomenon. It involves observing a brief brightening of a star when an object passes in front of it, a concept first predicted by Albert Einstein, who doubted it could ever be observed. Yet, thanks to technological advancements, what was once deemed impossible is now becoming reality. Though gravitational microlensing has proven Einstein wrong by being observable, it's still a hit or miss method. That's why it took the incredible sensitivity of the James Webb Space Telescope, JWST, to definitively identify the JUMBOs. These newly discovered planets are young, just about 1 million years old compared to Earth's 4.5 billion years. But it's not their age that has astronomers scratching their heads, it's their behavior. Unlike typical rogue planets that either drift aimlessly through space or cling to the orbit of a nearby star, JUMBOs orbit each other, separated by a staggering 200 astronomical units. A U that's 200 times the distance between Earth and the Sun. This isn't just exciting, it's perplexing. The JUMBOs challenge everything we thought we knew about planetary formation, orbital dynamics, and even the nature of the universe itself. Just when we think we've got the cosmic rules figured out, the universe throws us a curveball, and with each new discovery, our understanding deepens. What other marvels are out there, waiting to be uncovered? Binary systems aren't unusual in our galaxy. In fact, they're pretty common. especially among stars. Roughly 1/3 of all stars in the Milky Way exist in binary or even more complex systems, where two or more stars orbit a common center of gravity. But here's the catch: the smaller the objects, the less likely they are to form binary systems. For instance, around 75% of. Did you know that massive stars often have companions? About 50% of stars the size of our Sun are in binary systems, and for smaller stars, the odds drop to around 25%. But here's where things get really interesting. When you go smaller than a brown dwarf, objects that can't sustain hydrogen fusion and are only 15 to 75 times the size of Jupiter binary systems should be virtually impossible. At least, that's what theory says. Enter the James Webb Space Telescope, JWST, which has once again rewritten the rulebook. During its survey of the Orion Nebula, JWST discovered 540 planetary mass objects smaller than brown dwarfs. Astonishingly, 9% of these were in binary pairs, and 2 even formed a triplet system. This discovery isn't just surprising, it's game-changing. It completely defies existing models of planetary formation and flies in the face of what we thought was possible. At 9%, the occurrence rate of these Jupiter mass binary objects, nicknamed jumbos, is far too high to be a coincidence. Scientists are now scrambling to reconsider how planets and similar objects form. So, how do these jumbos come into existence? There are 2 leading theories, but neither fully explains the data. One theory suggests they might form like stars, collapsing from dense clouds of gas. The other theory is that they're born from chaotic, early planetary systems. Imagine a young Earth surrounded by molten rock, comets, and space debris, where dust clumps into rocks, rocks into asteroids, and eventually into planets. But even this chaotic model struggles to explain how such massive objects could form stable binary or triplet systems. The journey from dust to planets is chaotic and perilous. In young planetary systems, swirling dust clumps into rocks, rocks into asteroids, and eventually into fully formed planets. But not everything makes it through this cosmic crucible. Gravity can catapult material out of the system entirely, turning it into rogue planets without a home. Even massive planets aren't safe from this fate. Under the right conditions, they too can be flung into the vastness of space. Some scientists believe our own solar system may have once hosted an additional gas giant, only to have it expelled by the gravitational tug-of-war between Jupiter or Saturn. If true, it highlights just how volatile planetary systems can be. This ejection mechanism could explain why the galaxy may be teeming with rogue planets, possibly numbering in the billions or even trillions. But here's the catch. This theory doesn't explain the 9% of jumbos forming binary systems. The odds of 2 rogue planets being ejected together at precisely the same speed and trajectory, then capturing each other in a gravitational dance, are astronomically low, virtually impossible. That's where the second theory comes in. Some scientists propose that jumbos might form directly in interstellar space, much like stars. When stars are born, gravity pulls gas and dust together until the mass ignites nuclear fusion. In the chaotic environment of a nebula, where supernovae and solar winds scatter material far and wide, it's possible that smaller objects could form before they gather enough mass to ignite as stars. However, this still leaves us with more questions than answers. Are jumbos failed stars? Or are they a new type of celestial object altogether? One thing's for sure. The universe continues to challenge what we think we know, and JWST is just getting started. There's a major roadblock in the second theory of jumbo formation, the opacity limit. Here's the problem when gas and dust collapse under gravity. The gravitational energy is converted into heat. For the object to keep growing, it has to radiate that heat away. But as the object gets denser, it becomes more opaque, trapping the heat inside. This creates internal pressure that resists further collapse, effectively putting a cap on how small a forming object can be. Typically, this limit is no smaller than a brown dwarf. In simple terms, interstellar gas and dust either form something big, like a star or brown dwarf, or nothing at all. Without the gravitational influence of a nearby star or an incredibly dense environment, smaller objects like jumbos shouldn't be able to form. Yet, here we are. The discovery of binary jumbos throws a wrench in both formation theories. The idea that they're ejected planets doesn't explain how so many pairs exist, and the notion of them forming directly in space runs into the opacity limit. And just when it couldn't get more puzzling, we find triplet systems 3 jumbos, gravitationally linked, making the mystery even deeper. These findings suggest that our understanding of planetary and stellar formation isn't just incomplete, it might be fundamentally flawed. The processes governing how stars and planets form could be more intricate and less predictable than we've ever imagined. The Orion Nebula has become a hotbed for these cosmic surprises, and as we dig deeper, it's clear the universe still holds secrets that challenge our most established theories. What's next? Only time and perhaps the James Webb Space Telescope will tell. Jumbos are shaking up the rules of astrophysics, and scientists are scrambling to understand what this means for our broader understanding of the cosmos. Are these strange binary systems unique to the Orion Nebula, or could they be hiding elsewhere in the vastness of interstellar space? For now, the answers remain just out of reach, leaving us with more questions than ever. Here's the dilemma. When gas and dust collapse under gravity, they face resistance from heat. If the gas can't radiate that heat away, the collapse stops. But if it manages to push through this barrier, the momentum often overshoots, forming something much bigger like a brown dwarf or nothing at all. This phenomenon, known as the opacity limit, sets a minimum mass for objects forming in interstellar space. So, how are Jumbo's Jupiter mass binary objects defying this limit? Scientists suspect there's an unknown factor at play, one that's allowing these smaller objects to form in environments where they shouldn't. Cracking this mystery could lead to a breakthrough in understanding how planets and similar bodies form naturally from interstellar matter. One intriguing possibility: if 2 small objects form close enough to each other, their mutual gravitational pull could stabilize their orbits, no star required. This theory sidesteps the improbabilities of earlier ideas, such as planetary ejection or random gravitational capture, and offers a simpler, more elegant explanation. If proven, this could revolutionize how we think about planetary formation in deep space. For now, though, the jumbos remain one of the most exciting puzzles in modern astrophysics, and the race to solve it is only just beginning. The idea of rogue planets randomly pairing up seems miraculous, but what if it's not so rare after all? If Jumbo's Jupiter mass binary objects can form this way, it opens up the possibility that smaller planets, even Earth-sized or tinier, could follow the same pattern. These smaller planets could be out there, hidden in the vastness of space, beyond the detection limits of even the powerful James Webb Space Telescope, JWST. But maybe the answer isn't in something entirely new. It could lie in revisiting an older idea. Back in 2001, long before jumbos were on anyone's radar, astrophysicist Alan P. Boss proposed a groundbreaking theory in the Astrophysical Journal. He suggested that magnetic fields could play a crucial role in planet formation under certain conditions. According to his model, interstellar magnetic fields might expel a Jupiter-sized object from a collapsing cloud that would otherwise form a brown dwarf or star. Instead of being swallowed up, this smaller planet mass object would remain intact while the rest of the cloud continued collapsing into a larger celestial body. At the time, Boss's theory was purely speculative. There was no observational evidence to support it. Fast forward to today, and JWST's discovery of jumbos aligns remarkably well with the sizes Boss predicted. Maybe these binary jumbos aren't as unexpected as they seem. Perhaps magnetism is the missing piece of the puzzle we've been overlooking. It's still too early to say for certain whether magnetic fields hold the key to solving this mystery, but if Boss's theory is right, we may need to rethink how planets form, not just around stars, but in the vast, untamed regions of interstellar space. The mystery of jumbos remains unsolved, but it stands as one of the most intriguing possibilities in modern astrophysics. Understanding these enigmatic objects will take more than speculation. It demands cutting-edge observations, advanced simulations, and bold, creative thinking to refine our current models of star and planet formation. One thing is clear: jumbos pose a direct challenge to the established frameworks of astrophysics. Our current models can't explain how objects this massive form in interstellar space without the gravitational influence of a star, or how they manage to pair up into stable binary systems. This gap in our understanding isn't a setback, it's an exciting frontier waiting to be explored. Future research will likely push beyond what the James Webb Space Telescope, JWST, can do. We may need even more advanced telescopes or instruments specifically designed to detect faint, isolated objects like jumbos. Techniques like gravitational microlensing, where the gravity of an unseen object briefly magnifies the light of a distant star, could help identify smaller binary systems or uncover more jumbos in regions beyond Orion. High-resolution computer simulations will also play a crucial role in testing theories, such as whether magnetic fields or other overlooked forces contribute to jumbo formation. By combining observation with simulation, scientists might finally crack the code of how these massive objects defy the odds and reshape our understanding of the cosmos. The question isn't just how jumbos exist, it's what else their discovery might reveal about the hidden workings of the universe. Magnetic fields or other physical mechanisms might be at play, shaping these rogue binaries in ways we never expected. At its core, the discovery of jumbos serves as a powerful reminder of how much there is still to uncover about the universe. Every unexpected finding, every anomaly, challenges scientists to rethink long-held assumptions, pushing the boundaries of what we know and opening doors to new questions we never even thought to ask. Jumbos aren't just a cosmic oddity, they're a potential glimpse into the earliest stages of planetary and stellar formation. By understanding how these objects form, we might uncover insights into the processes that shaped our own solar system billions of years ago. Could jumbos represent an entirely new class of celestial objects? Could they be more common than we currently realize, hidden in the vast, uncharted space between the stars? Their discovery also suggests a universe far more chaotic and dynamic than we previously imagined. If planets and planet-like objects can form and survive in conditions once thought impossible, what other surprises might be lurking out there? Are there entirely different processes at work in the formation of celestial bodies? Or does this discovery simply highlight the incredible diversity of cosmic phenomena? The more we learn, the more we realize that the universe holds far more mysteries than we ever expected, and the answers could redefine everything we thought we knew. So, what exactly are jumbos? They are massive, mysterious objects that defy everything we thought we knew about planetary formation. Jupiter-sized wanderers paired together in a gravitational dance through the dark expanse of interstellar space. No star anchors their orbits, yet they move in perfect harmony, a testament to the strange and beautiful physics of the cosmos. But jumbos are more than just an astronomical curiosity. They may hold the key to unlocking deeper truths about how stars and planets form. Their existence challenges our current understanding, forcing us to confront the limits of our knowledge and pushing us to imagine new possibilities. As we peer deeper into the universe, jumbos remind us that science thrives on the unexpected and that some of the greatest discoveries come from the questions we haven't even thought to ask. Jumbos are a challenge, a mystery, and an opportunity that could ultimately reshape the way we understand the cosmos. And isn't that what makes the pursuit of knowledge so thrilling? Humans have always been captivated by the unknown, and space represents the ultimate frontier, a place where every discovery can redefine the limits of what we believe is possible. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blisovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blisovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.